Welcome back. Today we're doing a deep dive into AgentFounder. It's a really interesting new way to train these deep research agents. And the sources we've looked at, they really highlight this core problem with, well, the old way of doing things. They call it optimization tension.
Right. Optimization tension. It's this idea that, fine-tuning a big general model to do agent stuff planning, using tools, reasoning,
Yeah.
bringing, while also trying to align it, make it safe, and follow instructions. Well, that puts the model in a bind.
Exactly. It's like trying to teach someone advanced calculus and basic manners in the exact same lesson. It just limits how good the agent can actually become.
Yeah, you sort of end up mediocre at both.
Yeah.
So Agent Founder's big idea is structural. They said, look, you can't effectively do capability and compliance in that final step. So they added this intermediate stage. It's called Agentic Continual Pre-training, Agentic CPT.
Agentic CPT.
Okay. And our mission here is really to unpack how this extra step creates a much better foundation, a sort of agentic foundation model. Even with their Agent Founder 30B version, it's already beating the state of the art.
So it sits between the big initial pre-training and the final fine-tuning or alignment, like an agent boot camp.
Precisely. You get the general knowledge, then you specialize in being an agent during CPT, and then you get the final alignment for specific tasks. It separates learning how to act from learning what to do.
But hang on, doesn't that just mean, like, more training? Why is adding a step so effective?
Because that CPT stage needs a ton of very specific data, agent-like data. And this is maybe the coolest part. The sources detail 2 totally new ways they generate hundreds of billions of tokens of this data offline. And crucially, API-free.
API-free. Okay, that's big. That bypasses a huge bottleneck, right? The cost and time of hitting external tools constantly during training.
Exactly. It's a massive technical debt workaround you pay upfront in data synthesis, not continuously in API calls.
All right, so let's get into these methods. What's the first one?
The first is first-order action synthesis, or FAS. This is all about teaching basic planning, decomposing tasks. It uses this internal knowledge base, like a big database of facts they call an entity-anchored open-world memory. And from that, it generates really complex, multi-step questions.
Okay, but where's the efficiency? You said API-free.
Right, here's the clever bit. FAS synthesizes the thought process for the plan, and the very first tool call needed, say, the first search query.
I see. So it generates the plan idea and the first step's action.
But it never actually runs that search query or calls the API. It stops right there.
So you get massive amounts of planning practice data, basically for free, instantly.
Pretty much.
Yeah.
Okay, so that's FAS for the initial planning. The second method is high-order action synthesis, or HAS. HAS tackles the harder stuff, learning from choices, learning from mistakes, adapting mid-task.
Learning from mistakes. How does that work with synthesized data?
Well, this is where they get really smart. They reuse all the trajectory data, even paths that failed or weren't optimal in previous runs or other contexts. Instead of just showing the model the single correct path, Hayes reframes it. It's called contrastive decision action synthesis.
Contrastive, meaning?
Meaning at each step, the model doesn't just see the right action. It also sees alternative thought that could have had, or different tool calls it could have made, especially the ones that would have led to errors.
So it's not just imitating success, it's learning to recognize and actively avoid failure points by seeing the wrong turns it could have taken.
Exactly. It moves way beyond just sequence mimicry. It teaches robust, step-by-step decision-making, understanding why one choice is better than another.
Okay, wow. So pulling this together, what's the takeaway for you listening, if you're actually building these agent systems? It sounds like the big message is rethink the training pipeline, that dedicated CPT stage, separating capability from compliance. That seems key for performance.
Absolutely. And the offline data synthesis, FAS and H8S, gives you a practical blueprint for fighting that CPT stage without breaking the bank on API calls.
So the agent skills scale up with model size and the CPT data.
Predictably, yes. But the robustness, the ability to handle tricky situations, that really comes from the H8S method. Training on that whole space of possible actions, including the failures, makes the agent much more adaptable.
So the core insight seems to be separating the learning to be an agent part from the aligning the agent part, using really smart, efficient data generation in that middle step.
That's the heart of it. And it leaves us with a really interesting thought, maybe for you to ponder. If the secret to making more robust AI agents is teaching them to learn from their own hypothetical failures and consider alternative paths, how could we apply that same idea, that contrastive decision-making, to how we learn new skills, or how we teach others? Something to think about.